Hey y'all, today is March 4th and we did lesson 6-4 in class. This blank worksheet is posted in Google Classroom, so if you were not here or if you need another copy, go grab it from Google Classroom and print it so that you can follow along. Okay, let's get started with example 1. Quinn collects data from a random sample of 20 7th grade students who participate in a youth fitness program. She compares the number of crunches each student completed in 30 seconds last year and this year. What can Quinn infer from her comparison of the data sets? Okay, so let's look at our data sets. So in green, up here at the top, we have our dot plot for crunches completed last year. And in blue down here on the bottom, we have crunches completed this year, another dot plot. So we're comparing these two data sets. Now, one of the first things I notice is my mode, the number that occurs most often. For last year, it was 24, and for this year, it's 28. So based on that, I would guess that the number of crunches completed this year is greater than the number of crunches completed last year. Another reason I say that same inference is because when I look at the way the data is distributed, I have quite a bit of data from 28 to 30 for this year. But from 28 to 30 for last year, I really don't have I don't have any data. So I think that that's going to mean that there were more crunches completed this year than last year. So that's my guess. But mathematically, I can confirm that or correct that guess by finding the mean. So I'm going to find the mean for each dot plot. So to find the mean for each dot plot, I need to add up all of my data values. So I go kind of by columns of data. So my first column, I've got 20. Then I have 21 times 2, which is 42. 22 times 2 is 44. 23 times 4 is going to be 92. Then I have 24 times 1, 2, 3, 4, 5, which is 120. 25 times 3 is 75. 26 times 2 is 52. And 27 times 1 is simply 27. That's all the data that I have for that first one. And when I put that in my calculator and add that all up, I get 472. Now, 472 is the total of all my data. It is not my mean. So to make that my mean, I take my total, 472, and I divide by the number of dots. And if you go back and you count the number of dots, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There are 20 dots. So 472 divided by 20, when I put that into my calculator, I get 23.6. That right there is my mean. Now let's look at the mean for this year. So my first few data points are kind of standalone data points. So I've got 21 plus 22 plus 23 plus 24. Then I've got 2 times 25, which is 50. 2 times 26 is 52. 3 times 27 is 81. Oops. Then I've got 4 times 28, which is 112. I've got 3 times 29, which is 87. And I've got 2 times 30, which is 60. So I'm going to add up all of that data, put that in my calculator, and when I add it all up, I get 532. So 532. Now that is not my mean. It's just the total of all of my data. It's the sum of all of my data. So I'm going to take that sum, 532, and I'm going to divide it by the number of dots on the dot plot. And I'm guessing it's 20, but I just want to double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 20 was correct. And when I put 532 divided by 20 in my calculator, I get 26.6. So 26.6 is my mean. So let's write our inference. The number of crunches completed this year is blank compared to last year. Well, we had guessed that it would be greater based on the mode, based on the way the data was distributed, and it was more pushed farther to the right. But looking at my mean, I can confirm that because 26.6 is bigger than 23.6. So the number of crunches completed this year is greater compared to last year, or it's bigger compared to last year, or it's more compared to last year. Any of those words work. Okay, let's look at example 2. The dot plot shows a random sample of vertical leap heights of basketball players in 2 different basketball camps. Compare the mean values of the dot plots. Round to the nearest 10th. Okay, so let's look at our inference that they have for us. The mean values tell you that participants in camp blank jump higher in general. Okay, so we know we're looking at the camp where they jump higher. So let's look at our data here. So some things that I noticed. The first thing I noticed is the mode, the number that occurs most often. In camp 1, I've got 3 dots at 27. And in camp 2, I have 3 dots at 22. So those are my 2 modes. So based on the mode alone, I'm guessing that they jump higher in general at camp 1. Okay, because my mode is higher. 27 is bigger than 22. Okay, now another thing I look at. See how I've got quite a few data points from 18 to 22 in camp 2? Well, I only have 1 data point there in camp 1. It's like the data is more to the right for camp 1 than it is for camp 2. I can also look at it the other way. There's more data for camp 1 between 32 and 34 than there is for camp 2 in that same area. So again, it's like the data in camp 1 is further to the right than it is for camp 2. So if I had to guess, I would fill this in with a camp 1. They jump higher in general at camp 1. But let's verify that, and we're going to verify that with the mean. So I'm going to find the mean for camp 1 first. So I'm going to add up all of my data. So we start with 22, then we have 23, then I have 25 times 2, which is 50, then I have 27 times 3, which is 81, then I have 28, then I have 32, then 33, and last I have 34. So when I add all of that up in my calculator, I get 303. Now that's not my mean, that's just the sum of all of my data added together. So I'm going to take that sum and I'm going to divide it by the number of dots, and that's what's going to give me my mean. So how many dots were there? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 dots. So 303 divided by 11. When I put that into my calculator, I get 27.54, and that 54 repeats. So 27.54 repeating is my mean. Now, let's find the mean for camp 2. So I'm going to do the same thing. So my first data point is 18. My second data point is 21. And then I've got 3 data points at 22. So 22 times 3 is 66. I've got 2 data points at 24, which is 48. I've got 1 at 26. I've got 1 at 29. And I have 2 at 30, so that's 60. When I add all of that up, I get 268. Now 268 is not my mean, it is my sum. So to get the mean, I take that sum, 268, and I divide by the number of dots. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 11 dots in this graph as well. So 268 divided by 11, when I put that into my calculator, I get 24.36 repeating. So that is my mean for camp 2. Well, what do you notice? Hopefully you notice that one is bigger. So that means at camp 1, they jump higher in general. Participants in camp 1 jump higher in general. Okay. Now let's look at example 3. If you compare the means of each data set, who spends more time online? So looking at these two graphs, well, what do I notice? The first thing I usually notice is the mode. The mode for 7th grade is 90 minutes, and the mode for 8th grade is 120 minutes. Well, which one's bigger? The mode for 8th grade. So let's also look at the way the data is distributed. What I notice is that in the last two columns, I have a lot more data for 8th grade than I have for 7th grade. So there's more data further to the right for 8th grade than for 7th grade. That's telling me that, along with the mode, is telling me that 8th graders probably spend more time online. So I'm going to go ahead and answer that question here. So I'm going to say 8th grade spends more time online. Now, how can I either verify or correct my inference? I can find the mean, and if the mean tells me I need to correct it, I will correct it. But if the mean confirms that 8th grade is the group that spends more time online, then I will leave it as is. So let's first find the mean for 7th grade. So I'm going to add up all of our data together. So 30 times 2 is 60. Oops. 30 times 2 is 60. 60 times 4 is 240. 90 times 1, 2, 3, 4, 5, 6, 7 is 630. 120 times 4 is 480. 150 times 2 is 300. And then I have 180. Okay, so that's what I need to add up together. 60 plus 240 plus 630 plus 480 plus 300 plus 180. When I put that into my calculator, I get 1,890. Okay, that's just the sum. So let's make that a mean. So for 7th grade, we take our sum and we divide it by the total number of dots. Well, I don't know how many dots there are, so let's find out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There are 20 dots. So I'm going to put that into my calculator. 1,890 divided by 20 is going to give me 94.5. Okay, so that is my mean for 7th grade. Let's see if we can figure out our mean for 8th grade. I'm going to use a little teacher magic to move this over so I have some more room. Okay, so now looking at 8th grade, our first data point is 30. Then I have 2 at 60, so that's 120. 3 at 90, so that's 270. Then I have 1, 2, 3, 4, 5, 6, 7, 8 at 120. 8 times 120 is going to be 960. Okay. Then I have 150 times 4, which is 600. And last, I have 180 times 2, which is 360. So I'm going to add all of those numbers up together. 30 plus 120 plus 270 plus 960 plus 600 plus 360. All of that added together is going to give you 2,340. So that's just my sum. To make that a mean, I take my sum, 2,340, and I divide by the number of dots. Well, I don't know how many dots there are. I'm going to guess 20, but let's double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There are indeed 20 dots. Okay, so 2,340 divided by 20. When I put that into my calculator, I get 117. So 117 is my mean for 8th grade. So again, who spends more time online? We had said 8th grade. Does our mean confirm that? Yes, our mean for 8th grade is bigger, So we know that our inference is correct. Okay, let's move on to the back page. Sort the following vocab terms into the correct group. So they're either going to be a measure of center or a measure of variability. Okay, so let's talk about mean. Mean being our first word. We've done a lot of means today. We've calculated a lot of means. Mean is a measure of center. It's the average. Okay, what about mean absolute deviation? We talked a lot about that yesterday. Mean absolute deviation is a measure of variability. It tells you how spread out your data is. So mean absolute deviation, I'm going to put over here. And I'm also going to put the abbreviation next to it. Remember, MAD is the abbreviation, and you will see that abbreviation on your test. Okay? Now, median. Median, it literally means middle. And middle should remind you of this word, center. So, median is a measure of center. Okay? Now, interquartile range. The box, the length of the box, that tells you how spread out your data is, which is a measure of variability. So, interquartile range. I'm also going to put that abbreviation there, IQR. You need to know what that means for your test. And then finally, range, the maximum minus the minimum. Well, that tells you how spread out your data is. So the range is also a measure of variability. Okay, now you need to know this for your test. This will come up as a test question on your test, and I do not want you to be surprised. So measures of center are mean, the average, and median, the actual middle of the data. Measures of variability tell you how spread out your data is. Mean absolute deviation, or MAD, interquartile range, or IQR, and range are all three measures of variability. Okay, so now that we've gone over that, let's actually review mean absolute deviation from yesterday. And the way I set this question up is very similar to your test. You're going to have two groups of data, each with 5 terms. And in part A, you're going to find the MAD, the mean absolute deviation, for each group, and then you will complete a statement in part B. So it says, John recorded the number of pages of 5 fiction books and 5 nonfiction books that he read this year. And I know I need to find the MAD for both groups. So I'm just going to go ahead and start with my fiction group. And the way I like to do this is I like to write my data in a vertical line. So we have 120, then we have 115, then we have 135, then we have 140, and last we have 105, right? So you don't have to order your data. But my first step is to add these all up. And when I add them all up, I'm going to use a little teacher magic, see if I can do something here. Move them just slightly over. There we go. So when I add them all up, what do I get? Well, when I put that in my calculator, I get 615. Now I'm trying to find the mean first. That's my first step. So to take that sum and make it a mean, I'm dividing by the number of terms, 5. And 615 divided by 5 is 123. Now 123 is the mean. It is not the mean absolute deviation, but this will be a possible answer on your test. The test will try to trick you in that way. Remember, mean absolute deviation is always much smaller than the mean, so don't fall for that trick. Okay, now once I've found the mean, I'm going to subtract the mean from each term. So 120 minus 123 is negative 3. 115 minus 123 is negative 8. 135 minus 123 is 12. 140 minus 123 is going to be 17, and 105 minus 123 is negative 18. Okay, so we have a new set of data now. These numbers here. So what am I going to do with those new numbers? First, I'm going to make them all positive. So 3, 8, 12, 17, and 18. Now I want to find the mean of these new numbers, so I need to add them up. 3 plus 8 plus 12 plus 17 plus 18. When I put that in my calculator, I get 58. Now I need to divide that by the number of terms, 5. And 58 divided by 5 is 11.6. That right there is the mean absolute deviation for my fiction books. So on average, they vary by about 11.6 pages, almost 12 pages. Okay, so let's find the MAD for our nonfiction books. So again, I'm going to start by writing my data in a vertical line. So I have 155. Sorry, y'all. All these messages. 155. Then I have 198. Then I have 205. Then I have 201. And then I have 176. Okay? Now the first thing I need to do is add these all up. So I'm going to put them in my calculator. And when I put them in my calculator, I get 935. Now what do? Well, I need to divide that by the number of terms, 5. So 935 divided by 5. When I put that in my calculator, I get 187. So 187. Again, that's my mean. My mean absolute deviation should be much smaller than that. Okay? So now that I have my mean, though, I'm going to subtract each term by the mean. So 155 minus 187, when I put that into my calculator, I get negative 32. Okay? Now I'm going to take 198 and subtract 187. And when I put that into my calculator, I get 11. 205 minus 187. When I put that into my calculator, I get 18. 201 minus 187. When I put that into my calculator, I get 14. And last, 176 minus 187. When I put that into my calculator, I get negative 11. So now I have new data right here. That's what I'm using from now on. Now, first thing I need to do, make them all positive. So 32, 11, 18, 14, and 11. I need to add all those up. So when I put those into my calculator, 32 plus 11 plus 18 plus 14 plus 11 is 86. And I need to divide that by the number of terms that I have, which is 5. 86 divided by 5, when I put that into my calculator, is 17.2. So 17.2, what is significant about that? Well, that is the mean absolute deviation for my nonfiction books. So on average, they vary by about 17 pages. Okay? So now, let's complete part A. The MAD number of pages for fiction books. Well, we found that right here is 11.6. The MAD number of pages for nonfiction books, we have that over here, is 17.2. So the blank books have greater variability. That's key, greater variability. Well, the nonfiction books have a bigger number. So the nonfiction books have greater variability. And I know that because the value of the MAD is greater, or you could say bigger. Okay? So remember, the greater the mean absolute deviation, the greater the variability, the more spread out your data is. That is the end of our notes for lesson 6-4. Y'all have a great weekend.